Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will cover a topic of S2 where we talk about the type 1 and type 2 error. This is basically a continuation of the hypothesis test on binomial distribution. So if you haven't watched that video, you have to watch that video first to be able to understand this particular video. First of all, when you are performing a hypothesis test and you draw a conclusion, you have to acknowledge the fact that there is a possibility that your conclusion may be incorrect. That's a conclusion that you've drawn. That is your correct answer. But that conclusion on its own might be incorrect, and you wouldn't know that. So once you've drawn a conclusion, there might be an error in your conclusion, and if your conclusion has an error or if your result has an error, then that is called type 1 and type 2 error. There are overall 4 possible outcomes. Ideally, H0 is true and you have accepted H0, that's perfect. Or H1 is true and you have accepted H1, that's also perfect. But if H1 is true, but by mistake you have accepted H0, then this will be an error. Or if you have accepted H1 where originally H0 was true, then this type of error is called a type 1 error. So you can get a question where examiner may ask you to calculate the type 1 error and the type 2 error. So once you have identified the critical region, you know what part belongs to H1 and what part belongs to H0, that region's probability is going to be probability of type 1 and type 2 error. So as far as type 1 error is concerned, that's the probability of critical region when H0 is being true, because you have accepted H1. So with H0 being true, which is going to be part of your null hypothesis, if you find out the probability of the critical region, that will be the probability of type 1 error. So probability of type 1 error is equal to the probability of critical region. But please keep in mind that this is not always going to be equal to the significance level, because significance level, if you are taking a 5% significance level, that 5% might lie between any two values. So if let's say this is 7, this is 8, this is 9, this is 6, and your significance level of 5% was somewhere here, then you can't just simply say that my probability of type 1 error is the probability of significance level, so it should be 5%. No, because you have to take probabilities of these discrete integers. So you have to individually add the probability of 7 and probability of 8 and probability of 9. So that will come out to be slightly lesser than the significance level, but that will be the probability of type 1 error. Similarly, if you have to find out the probability of type 2 error, you have to find out the probability of non-critical region, the region of the acceptance of H0. But there is one thing to be noticed, and that is if it is a type 2 error, which means that H0 is not true and H1 is true, so your probability value that you took from the null hypothesis is not going to be valid anymore. So that means every time you have to calculate the probability of type 2 error, you have to calculate the probability of non-critical region, but not with the probability stated in H0. There will be a new probability given to you, and you will use that probability, which will be out of the acceptance of H0 and which will be satisfying H1, but that is the probability you will take to find out the probability of non-critical region. So that will be your type 2 error. Let's have a look at an example where the question says the random variable x can be modeled by a binomial distribution with parameters n and p whose value is unknown. Find at the 10% significance level the critical region to test the null hypothesis of p equals 0.3 against p is greater than 0.3. So obviously you have probability H0 probability is 0.3 and H1 is probability greater than 0.3. So then if you have to find out the 10% significance level, you try and find out the critical region by seeing that what part of the upper tail contains the 10% significance level. So you start doing your cumulative probabilities. probability of 9, probability of 9 plus 8, probability of 9 plus 8 plus 7, and so on and so forth. And you will see where it crosses the 10%. So you see probability of x is greater than or equal to 5 is coming out to be 9.452%, whereas probability of x is greater than or equal to 4 is coming out to be 26.6%. This is where it crosses 10%. So that means your critical region lies between 5 and 4. And since probability of alternate hypothesis is greater than 0.3, your critical region lies at the upper tail. Hence, the critical region would lie above 5. So it will be 5 and greater than or equal to 5. Once we have found out the critical region, it says what is meant by type 1 error. So type 1 error is when H0 is true, but we have accepted H1. And then if we have to find out the probability of making a type 1 error, so probability of type 1 error is going to be probability of a critical region, which will be greater than or equal to 5, and that's going to be 0.09452. So you see it comes out to be slightly lesser than 10%, but yeah, that is going to be your probability of type 1 error. Let's say we add another part to this question where it says if instead H0 is accepted where probability is 0.6. So that means that there is a type 2 error and we have to calculate that probability. So probability of type 2 error would be less than or equal to 4 probability, that is the probability of non-critical region, but with this new probability being given to you. So you use probability 0.6 and it's still 9, but you just calculate the probability of less than or equal to 4. You add them all up and you will get yourself the probability required. Let's have a look at some past paper examples of this. So this is a question taken from June 19, variant 73. It says there are 4 sides of the spinners. The spinner is supposed to be fair, which means that each side will get a probability of 1 upon 4. But Sonam suspects that the spinner is biased, so that the probability P, it will land on side A, is greater than 1 over 4. He spins the spinner 10 times and finds that it lands inside A 6 times. Test the Sonam's suspicion using a 1% significance level. So since it says that suspicion is for the probability is to be greater than 1 over 4, so H0 will be probability is equal to 1 over 4 and H1 is going to be probability is greater than 1 over 4. You write down a distribution, you know that the test value is 6. So once you will find out the probability of greater than or equal to 6 and it comes out to be 1.97, that is greater than 1%, which is the significance level. So that means your test value 6 lies outside the critical region, which means H1 is going to be rejected and H0 is going to be accepted. That is, spinner is biased in favor of side A. Moving on with this question, it says later Sonam carries out a similar test at 1% significance level using another 10 spins of the spinner. Calculate the probability of type 1 error. We have to calculate the probability of type 1 error. Type 1 error means that we have to calculate the probability of critical region. We've already seen that probability of greater than or equal to 6 is 1.97%. And the critical region is where the probability greater than 1% must be lying. So we test it on 7 and we found out that greater than or equal to 7 is coming out to be 0.00351 and that is going to be 0.351%. So that is less than 1%. So that means that greater than or equal to 7 is the critical region and this entire probability is going to be your probability of type 1 error. Let's have a look at another part of the question. It says now assuming that the value of P is actually 3 by 5. So that means probability is not 1 over 4. The H0 is not true and we have to calculate the probability of type 2 error. I did tell you that every time you have to find out the probability of non-critical regions acceptance, you will be given an alternate probability. Just like in this case, it's given as 3 over 5. So x follows a binomial with 10 and 3 over 5. You know your critical region is 7 or more, so non-critical region would be 6 or less. So you have to calculate the probability of 6 or less, and the easier approach would be that you do 1 minus probability of 7 or more. So once you do that, and that comes out to be 0.618, that is the probability of non-critical region acceptance of H0 region with the new probability that's given to you. So this is the probability probability. Remember, this is the probability of an error. This is the probability of type 2 error. If actual probability was 3 by 5 and not the one stated in the null hypothesis, then for the non-critical region and the acceptance of H naught, the probability of that particular region is going to be your probability of type 2 error. Let's have a look at another example. This is Feb-March paper 2018. It says packets of fruit gums contain 30 sweets. The manufacturer claims that on average 17% of the sweets are orange flavored. Angela suspects that the average is actually less than 78%. In order to test the manufacturer's claim, she buys a packet of fruit gums. If there are fewer than 3 orange flavored sweets in the packet, she will conclude that the claim is false. So H naught probability is 0.17 and she thinks there are fewer, so probability for alternate hypothesis would be less than 0.17. It says, what is meant by type 1 error in this situation? So type 1 error is where H naught is true, but H1 is accepted. So that means actually the probability is 0.17, but we have accepted that the probability is greater than 17%. Now, it says calculate the probability of type 1 error, and since your alternate hypothesis is less than 0.17, it is a one-tail, lower tail test, so you find out the probability of critical region at the lower tail. It was already suggested that if there are fewer than 3 orange flavored sweets, she will conclude that the claim is false. So that means that H1 will be accepted for 2 or less. So if H1 was going to be accepted for 2 or less, you already know the critical region. You just have to find out the probability of critical region. So we do that and we calculate the cumulative probability of less than equal to 2 with P being 0.17, and that comes out to be your probability of type 1 error. Then in the next case, we have to find out the probability of a type 2 error, but now the true percentage is given to us, which is 5%. So that's a new probability of orange flavored sweets, and we have to find out the probability of non-critical region. You rewrite the distribution, N is 30, P is now provided to you, which is 0.05, and then you have to calculate the probability of non-critical region. If critical region was less than equal to 2, then non-critical region would be greater than equal to 3. So that means you have to calculate the probability of greater than equal to 3. And once you will simplify this and find your result, that is going to be your probability of type 2 error. Thank you so much, guys. I hope this helped you towards understanding how to calculate the probability of type 1 and type 2 error. I would greatly appreciate if you would give a thumbs up and also subscribe to my channel.